All right, let's take a look at our lesson on completing the square. First, let's focus on our perfect square trinomial, the pattern. And I'm just going to remind you, the last lesson that we did, we had a perfect square trinomial. It was this one right here. So let's write that down and let's look at it. So it is r squared minus 16r. Okay, so that was r squared minus 16r plus 64 equals 0. Okay, so let's see how it fits this pattern right here. So b, in this case, was 16. And what this says is if the third term is b divided by 2 squared. Let's check that out. 16 divided by 2 is 8. And then if we square 8, we get 64. So see how that's a 64? So if we'd known this pattern, we would have been able to tell from the beginning in that last lesson that this is a perfect square trinomial. So do you have to memorize that pattern? No, it's just kind of cool that that is the pattern and that would show up. And when you when you have a perfect square trinomial, it's always going to factor exactly like that. This could be a plus or a minus depending on which scenario you have, but it's going to be x plus or minus b over 2 and that whole thing squared. So in this example we had here, so that would have been x minus, let's see, b 16 over 2 squared, so x minus 8 squared, and if we look up here, sure enough it was r minus 8 squared. So I think that's just fun. Just wanted to kind of go through that. Now these trinomials that we have right here are not perfect square trinomials, but we do have a technique that we can use called completing the square in order to force it to be a perfect square trinomial. And so what we're going to do is, I like steps, so I have all the steps written out. What we're going to do is we're going to practice that. We're going to force that trinomial to be a perfect square so that we can use this technique, and just an additional technique for us to solve our quadratic equations. So let's kind of jump in there. So these are the steps that we're going to take to practice, or basically to complete the square so we can solve. So the first step is to move the constant to the other side. So let's do that. So x squared plus 6x, and then we're going to move the negative 16 to the other side, so it'll be positive 16. So we just did step 1. Yay! All right, step 2, if a, so recall ax squared plus bx plus c equals 0. Remember, a is the number in front of x squared. If a is not 1, we would have to do step 2, factor it out to the left side. But in this case, a is 1, so we don't need to deal with that. Step 3, we're going to take half of b. Remember, b is the number in front of the x, so b is 6. So we're going to half it. Half of 6 is 3. We're going to square it. 3 squared is 9. And then we're going to add it to both sides. So some people like to do this, to put blanks there. So half of 6 is 3. 3 squared is 9. So I add 9, add 9. So that is step 3. Step 4, we factor. Now this piece right here is in the form of a perfect trinomial squared. So b in that case is 6. 6 divided by 2 is 3, and this is 3 squared, or 9. So it's going to factor exactly like this. It's going to be x plus b, so 6 over 2, which is 3 squared. I mean, you don't even have to, if you know the pattern, you don't even have to think about it. If you don't remember the pattern, then you certainly could go through the steps to factor this left side like FOIL using guess and check, and you're going to get that same thing. All right, then 16 and 9 is 25. So we just did step 4. So if there is, and you know, if A is not 1, you would have to do step 5. So let's kind of hook these together. Step 2 is hooked with step 5. Okay, but if A is 1, you don't do either step 2 or step 5. We'll do those later. So then we'll run to step 6. We're going to square root both sides. So we get x plus 3 is equal to, x plus 3 is equal to plus or minus. Remember, you may remember this from previous math classes. When you square root like an x plus 3 squared, then it generates a plus minus on the other side with the number, so plus minus 5. So my answer, I'm going to have two answers, and we can't leave it like that. I'm going to have x is 3 plus 5, or x is 3 minus 5. And so that gives us x is what, 8, and x is, what is that? Oops, nope. So 3, oops, this is negative because I had to move it over. See, it's a positive right here. I had to move it over. Negative 3 plus 5 is 2, and negative 3 minus 5 is a negative 8. So those are our two answers, and that's our very first completing the square. Yay! All right, so now let's practice that. We have another example with A is 1. So we're just going to try to go through this. You can have the steps out to the side if you want to. Actually, we can just keep them out to the side so you can see if you like. All right, so we're going to move the constant on the other side. We half of 8 is 4. 4 squared is 16. We factor. This is going to be x plus 4 squared equals 6. Then we square root both sides. We get x plus 4 is plus or minus the square root of 6. And then we get x is negative 4 plus or minus the square root of 6. Yay! Now you can leave them combined like that, or you could write them individually. I could have negative 4 plus root 6 and negative 4 minus root 6. Either one of those is fine. All right, let's go to the second page, and we have two more to practice. Now these do not have an A of 1, so they're a little bit trickier, but it's going to be okay. We've got this. So let's go through our procedure. Step 1, we move the constant over. So we've got 3x squared plus 12x equals negative 15. Now we're going to have to do step 2. We didn't have to do that on the other ones. We're going to have to factor out the 3 from the left side because that's A, right? A is 3. So we factor it out, it's GCF. And 12 divided by 3 is 4. And then now we can do our plus blank. All right, so B is 4. B is 4. It's not 12. We use the new B, the one where after we factored A out. So let's see, B is 4. So half of 4 is 2, and 2 squared is 4. So I'm going to add 4. But I'm not going to add 4 over here, and this is the part that sometimes is really confusing. On the left side, I did add a 4, but that's not what I changed the value. Remember how equations have to be balanced? I actually changed the value of this left side by 12. 3 times 4 is 12, right? That's what I changed the value of the left side by. So I have to do the same thing on the right side. I have to change the value of the right side by 12. And so that's something that we have to keep in mind. And I'll go back just to reference these steps. So see, what I'm talking about is we did step 3, if a was not 1, we want to be sure to adjust the numbering being added to the right side. See, that's what I did. I made sure that I didn't add 4 to the right side. I needed to add 3 times 4 to the right side. Okay, good, good, good. So let's clean this up. Let's do our next step, which is factoring. And negative 15 plus 12 is what, a negative 3. So now we go to step 5. I'm just going to remind you what step 5 is. Step 5 is multiply both sides by 1 over a. So basically what we're trying to do here is to isolate. We want to isolate this part right here. Okay, we want to divide both sides by 1 over a, or multiply both sides by 1 over a, excuse me. So I'm going to multiply by 1 over 3. Another way you could think about it is to divide both sides by 3. Really, it accomplishes the same thing, whatever is most helpful to you. Okay, great. So now we are in good shape. Now we want to go to our next step, which is to square root both sides. So x plus 2 equals plus or minus the square root of negative 1. Ooh, we got imaginaries going on here. Remember that from a previous lesson? So x is going to be, and I'm going to move the 2 over, plus or minus. Remember what the square root of negative 1 is? You're right, it's I. And so there's our solution, negative 2 plus or minus I. Okay, and we saved the best one for last. It's a crazy fraction one. I know you're super excited about that. So we're going to work one of these with a fraction. All right, let's do it. So I've got 1/3 x squared plus 2x. Let's move the negative 7, the 7 over to the other side. All right, great. Oh goodness, so I'm going to have to factor out a 1/3. Okay, that's weird. And factoring out a 1/3 from a 2 is just really weird. And so remember, we talked previously that factoring is dividing. So what I'm basically doing is I'm basically taking 2 divided by 1/3. And we know from elementary days that we don't like to divide fractions. We would much prefer to multiply them. So this is going to be equal to 2 times the reciprocal of 1/3, which is 3, or 6. So 2 divided by 1/3 is, strangely enough, 6. You're like, what? I know, it's crazy, right? Okay, and if you're worried that you did it wrong, you can check your work by just multiplying this out. You know, 1/3 times 6, yeah, that's 2. So you did it right. Okay, great. So now we're going to half b. b is 6. So let's see, half of 6 is 3. 3 squared is 9. We're going to add 9 here, but are we going to add 9 over here? Oh, be careful. Nope, nope, because what did we change the value of the left side by? We changed the value of the left side by 1/3 times 9, which is 3. That's what we changed the value by, so we need to counter that. Remember, equations are balanced. We need to counter that by adding 3 to the right side. Okay, good, good, we're doing good. So now we're going to factor, so that's x plus 3 squared equals, was that negative 4? Then we multiply both sides by 1 over a, or basically we're getting rid of a. So I have x plus 3 squared equals negative 12. We square root both sides. Oh goodness, we have the negative thing going on again. Let's go out here and do a factor tree on 12. Let's see, so what would we get? Move the 3, so plus or minus, let's see, the square root of 4 is 2, and then that negative 1 is I. And then what's left over, we have that little 3 left inside. All right, there we go. There's our last problem. Now it should look very similar to the answers that you get from another technique that we were working on, which was quadratic formula. So now we know how to solve by factoring, we know how to solve by quadratic formula, and now we know how to solve by completing the square.